Okay, welcome back. Today we're going to learn about insulators and conductors, but before we do that, I want to take a quick look at this video that reviews heat transfer. Okay, we're going to take a look at heat transfer. So remember, heat can be transferred three different ways: conduction with direct contact, convection and in currents, and through radiation.
Heat travels from one place to another in one of three ways: conduction, convection, or radiation. In solids, heat can travel from one particle to another. This is called conduction because the heat is conducted from one particle to another.
So imagine, like, if these are the particles in the end of this piece of brass here, and they're moving along and they're bumping into each other, and as they heat up, they move faster, 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 and faster, and then bump into each other. Well, they're going to start bumping into the particles in the handle. And so the heat is going to go from particle to particle, and it's going to conduct particle to particle up the handle.
For instance, if we hold a nail in a flame.
Same thing with these nails. Okay, the particles at the end of the nail are going to start moving faster, faster, and bump into them. And then they're going to start bumping into the particles and transfer the energy up the nail to where this person's fingers are.
After a short period of time, the nail will become too hot to hold. The flame has caused the particles at the end of the nail to vibrate vigorously. This vibrating passes from one particle to another until it has passed throughout the nail. Metals conduct heat very well. Some solids, such as wood, paper, cork, and styrofoam, are poor conductors of heat. They are called insulators. Wood is often used as the handles for frying pans because it is a poor conductor of heat energy.
So the particles in the pan will conduct the heat throughout the pan. But because the wood is a poor conductor, when the particles moving fast in the pan start to hit the particles in the handle doesn't transfer the heat very well.
And protects your hands from the heat of cooking when you handle the pan. Convection is the way heat is transferred with liquids and gases. When a liquid or gas is...
Now notice how it's rising. So it's going to rise along the edges, and then as it gets to the top, away from where the burner is, it's going to cool down a little bit. As it cools down, it's going to become more dense and start to sink. So it's going to create a rising and a sinking.
Heated, the particles do more than just vibrate. They move around to new locations. In the case of water heating on a stove, the bottom of the pot is heated, heating the water at the bottom, which begins to vibrate and move around. It becomes less dense and rises to the top of the pot. Cold water moves in to replace the heated water. This continues until all the water is heated and circulating. For either conduction or convection to work, particles of matter must be present to vibrate and move around.
Okay, that's a key concept. Okay, in order for the heat to conduct up the nail, it was required the particles at the end to gain energy and bump into the particles up the nail. In order for the convection to happen, the particles had to move faster, become less dense and rise, and then sink to the bottom. Okay, now this is different than radiation, which can travel through a place where there's no particles, like the vacuum of space.
However, heat can also travel without matter present. Heat from the sun travels through the emptiness of space. There are no particles of matter in space, but heat can still travel as waves of radiant energy. This kind of heat transfer is called radiation.
Okay, so as promised, we're going to learn about insulators and conductors. Okay, so there were three types of heat transfer: conduction, convection, and radiation. So when we think about insulating something, we want to stop the heat from flowing by those three methods. So a conductor is a material that allows the heat or electricity to move through it easily. So metals are examples of good conductors. And remember, conduction is from particle to particle. So the particles in the metal allow the energy to transfer through them easily. An insulator is a material that does not allow the heat to flow. So generally things where the particles are farther apart, they have a harder time transferring the energy from one particle to another. So gases, where the particles are the farthest apart, are usually good insulators. Now, the problem with gases is that they want to warm and rise and make convection currents. So if you can stop them from doing that, they make pretty good insulators. So it's harder for conduction and convection to take place since there are less particles and atoms to move. Okay. So when we look at insulation in a wall, okay, there's no insulation, there's just this space in the wall that's hollow. So what happens is that hollow space, the air inside that hollow space where there's no insulation starts to heat. When it heats, it starts to rise, and then it starts to expand, and it starts to create this convection current inside the wall. Now, a lot of times it'll also start to expand just in general, and there's vents to let the air out. So if the air is going out of the wall someplace, it needs to get cool air from somewhere. So either it pulls it in from the outside or it pulls it in from your home. Either way, it's transferring energy from heat energy from the outside or from the inside. So it's, it's allowing the heat to move in and out more easily. By trapping the air inside the wall with the insulator, it slows this process down. Okay. The vacuum layer is best. It's one of the best insulators since there's no atoms to transfer energy at all. Okay. Space is an example of a place where there's a vacuum and there are no particles to transfer energy. So remember, with convection, the matter expands and it rises. And with conduction, it's particle to particle. So if you can get rid of the matter, then you can't conduct or convect. Okay. Humans and animals insulate with fat, fur, and skin. Okay, so I want to review. Conduction is particle to particle, it's direct contact. Convection is movement of heat and currents, and radiation is an electromagnetic waves. So the first two, conduction and convection, require that there be matter present. There has to be particles for either direct contact or the current. With radiation, okay, it can travel through a vacuum. When it hits something, remember, radiation is either absorbed or reflected. So a vacuum where there's no particles can stop conduction and convection. Okay, because there's no atoms to transfer the thermal energy. There's no matter. So if we look at a thermos like this, some thermoses have like a double lining. They have the outside lining, and then they have an inside lining. And inside this area in here where you put the liquid or whatever you want to keep warm, it's often coated with a shiny coating. So, and in between the inside layer and the outside layer is a vacuum space. So since there's no particles in this vacuum space, it stops convection currents. It also stops conduction because there's no particles to move the energy by direct contact. Okay, that leaves radiation. Okay, the energy can radiate out because radiant energy, heat can transfer through a vacuum. This is why they put the shiny reflective surface on the inside. Okay, because radiant energy is either absorbed or reflected, and this reflected surface, okay, the heat hits it, and then it's reflected back in. So by having the vacuum, you stop conduction and convection. By having the shiny surface, you stop radiation. So this thermos works on all three methods of heat transfer. So the puffy stuff in the wall slows convection. What it does is it blocks the airflow. It keeps it from rising up inside the wall like this over here in this picture. Also, it's not a very good conductor, because the particles are far apart, that's why it's so puffy with light, okay, is they want the particles far apart so that when it traps the air and keeps the convection surface from stopping, it's also not a good conductor. And then in some homes, they want to stop the third flow of heat transfer, and they put this shiny, it's called a radiant barrier, inside attics and sometimes on the roof. And these reflective barriers are used to slow down radiation. So again, when people are thinking about insulating, they're trying to stop conduction, convection, and radiation. You know, I want you guys to answer the questions on this page. And we're going to stop here for now. And when we come back, we'll pick up here. I hope you're having a great day, and we'll see you next time.